Okay, this equation in polar coordinate is given by this guy. So it's clear, right? Now, let us go to another concept, the tangent to a polar curves, okay? Let us derive this together. Okay, this is simply a parametric equation. From parametric equation, we know that the tangent will be given by this relation. So we know that from chain rule, we know that dy over dx is simply dy over d theta divided by dx over d theta, right? And in polar coordinate, what is the equation of y in terms of r and theta? Yes, perfect. Thank you, Abigail and Luke. It is r sine theta, right? And what is the expression of x here? Thank you, Zachary. It is r cosine theta, right? So this is very important. And in polar coordinates, the radius is a function depending on theta, right? It is not a constant. So therefore, this derivative, we should use a product rule, right? And if you don't remember the product rule, it is like this. F times G derivative, it is F prime times G plus F times G prime here, right? Therefore, applying to this numerator, we have d over d theta of r, right, times sine theta, right? And what is the second terms of this product rule? Yes, let us do it slowly. dr times d over d theta of sine theta, right? Just do it slowly. And similarly, in the denominator, the same story. D over d theta of r times, what is it? Yes. And the next term will be? Thank you, Corner. Of cosine theta, okay? Now, we have all these expressions. Let us compute it together. So, this guy, d over d theta of sine theta gives us cosine theta, right? And here, d over d theta of cosine theta gives us negative sine theta. That is why we have this equation, equation 3. Okay, see why we have these terms? Okay, yes. Yeah. Thank you, Victoria. Yeah, copying it, and thank you very much. Good point. So, from now on, we can use the equation 3 as a formula, right? Okay. Therefore, now from in the future, if we want to compute the tangent, we can apply this formula immediately. But remember, in some special case. Oh, remember, this one is very important. The horizontal tangent. When the tangent is horizontal, it means that it is flat, right? Or dx over dy will be equal to 0. It is equal to 0, it means that the numerator of this guy will be 0, or dy over d theta should be 0. But this is a whole fraction. We need to do one more condition. That is, we need to prove that at that point, dx over d theta should, at that point, should not be 0. If you missed this part, the problem just happened, right? Be careful with that, because in the test 1, test 2, many people forgot checking that condition. Similarly, if the slope is horizontal, right, it means the tangent line will be horizontal, or the slope is going to infinity. It goes to infinity when this fraction, the numerator should be a constant, and the denominator will be 0. It will be a constant divided by a number 0. It means that we need to check these conditions. Dx over d0, dx over d theta is equal to 0, and dy over d theta should not be 0. We should check these two conditions. And some special case, when both dx over d theta and dy over d theta at some point, they're both 0, then we cannot apply this formula immediately, okay? But in that case, what we need to do, we substitute to here, right? When, so in a polar coordinate, suppose r is equal to 0, it means at the pole. When r is equal to 0, then we put into this formula, what is this product? If r is equal to 0, this one will be 0, right? And this one will also be 0. So these two are 0. So the equation 3 becomes dr over d theta times sine theta divided by dr over d theta times cosine theta. What happens if dr over d theta is equal to 0? Yes, it's undefined, right? This fraction is undefined. So we need to do, we have the condition that dr over d theta should not be 0, otherwise it is not defined. But in the case where dr over d theta is not 0, then we can cancel out, right? And this becomes, very good, thank you. Okay. So that is why we have this special case. dy over d theta and dy over dx will be tangent theta, and the condition is dr over d theta should not be 0. Okay, that's it. So go back to previous example when we have the equation. R is cosine of 2 theta, right? The special case when R is equal to 0, it means that, okay, let us copy it and make it clear. So we take a look at this example. We consider the special case when R is equal to 0, or it is equivalent to cosine of 2 theta should be 0, right? Okay, again, the unit circle tells us that cosine axis is here, sine axis is here. We don't care about how much it is, but it is an angle right here. Any angle, cosine of that angle is equal to 0 when it is, where is it in this unit circle? The angle should be pi over 2 or negative pi over 2, right? But yeah, either ways, pi over 2 or negative pi over 2. So cosine of pi over 2 is equal to cosine of negative pi over 2. They are both 0. Okay? Or in more generals, if we pick that point, in general, cosine of pi over 2, we add one more pi. It means we go in this direction one more pi. They will all give us the same result. Plus n pi, they are all 0. Where n is an integer. Okay? It's true for all n's. Okay? Therefore, so we know that cosine of pi plus n pi, pi over 2 plus n pi is equal to 0. Therefore, from these two, it means that 2 pi should be equal to, what is it? Thank you, Abigail. Okay. Cosine of this angle is equal to 0. Cosine of this general case is also equal to 0. Therefore, these two angles should be the same. Okay. If 2 theta is equal to pi over 2 plus n pi, what does it mean? Can we isolate theta? Yes. We divide both sides by 2. It gives us pi over 4 plus n pi over 2, right? Okay. Or we do it slowly. So it would be pi over 2 plus n pi divided by 2. This is a sum of two fractions. Therefore, let me remove this guy first. Therefore, theta will be pi over 4 plus n pi over 2. Okay? So let us pick some special angle between 0 and 2 pi. Therefore, we found two values, right? The first one is angle is pi over 4, which means when n is equal to 0. And the second choice would be theta is 3 pi over 4, right? Say it again, please. Okay, let us pick. Pi will be pi over 4 when n is equal to 0. When n is equal to 1, it will be pi over 4 plus pi over 2, which is 3 pi over 4, right? If n is equal to 2, it will be pi plus pi over 4, which means it will be 5 pi over 4 is still in 2 pi. 3, when n is equal to 3, it will be 3 pi over this and it becomes 7 pi over 4. But we care, but in this case, what is x and y? I mean, so look at this. They're the same lines, right? Pi over 4 here, pi over 4, and the angle theta is 5 pi over 4. In polar coordinate, they're the same things, right? And similar story, 3 pi over 4 here is the same as 7 pi over 4, okay? They're repeated. Do you see why we pick only 2 special values here? Because it's repeated. So just pick these 2. And for these 2 cases, the tangent lines is at the origin. Then we should compute it using this formula. Okay? This is at the pole. Anyway, the next example is very hard. It's not very hard, but this is how we apply the formulas. Okay, given the equation here, the choroidal equation, r is equal to 1 plus sine theta. We plot that curves already. Okay. And find the slope of this tangent line when theta is equal to pi over 3. What we need to do is to write the tangent formula down here, right? It is this forms, put everything we know here. So look at this. If r is 1 plus sine theta, what is dr over d theta? Yes, cosine theta only, right? Therefore, we plug it into this formula. We have this guy is cosine theta. And here sine theta is right here already. So that is why we have this product. Okay. The second terms, r is given by this forms. So we will replace it here. Okay. Times cosine here. In the denominator, the similar story. dr over d theta is cosine theta here times cosine theta minus r is given by this forms. Therefore, we have this. Okay. So this guy in the numerator, what is the like term? Yes, it means we can factor it out, right? If this guy, we factor it out, what is left inside? Yes, sine theta plus 1 plus another sine of theta, which means we have 1 plus 2 sine theta here. Oops. Okay, is it clear in the numerator? In the denominator, this guy, cosine times cosine. in this terms, we only have, when we distribute it, what do we have? Yes, it is negative of sine theta plus sine theta times sine theta, which is sine square theta, right? And here is cosine square theta, right? But the identity of trigonometry, we know that sine square theta plus cosine square theta will be? Yes. It means that we can write cosine theta is, cosine theta square is 1 minus sine square theta, right? It means we replace this guy by 1 minus sine square theta. Simplify it. And we got this denominator here. Okay? Are we good? Yes, just follow it. It's complicated, and so that's why we just follow it. So we can save a little more time. So again, we can factor it out. Is this guy. This is the equation of trigonometry function. In order to factor it out, you just simply imagine this is a quadratic function, 1 minus 2 x squared minus x, where x play a role of sine, right? And we factor it out, and this guy becomes 1 plus x times 1 minus 2x. That is why we have this equality here. Okay. Just follow the notes. Then, look at this. This is the tangent for any points, okay? So, specifically at theta is pi over 3, what we need to do is to substitute the value of the angle theta at pi over 3 to this formula, right? Which means the tangent here will be cosine of pi over 3 times 1 plus 2 sine of pi over 3 divided by 1 plus sine of pi over 3 times 1 minus 2 sine of pi over 3. Okay? Pi over 3 is a special angle. So remember this triangle. If this is 1, this is 2, this is pi over 3, this is pi over 6. The length of this should be square root of 3. Then sine of pi over 3 will be? Yes, square root of 3 over 2. Okay? So we just substitute the values here and simplify it. Okay? It will be this guy. You can simplify further. So, and it is, yeah, at that point, we can do it together. So how can we simplify this fraction? Remember, a squared minus b squared is a minus b times a plus b, right? And in our case, you can imagine that a is 1 and negative square root of 3, which means if you multiply this by what? What should we multiply here? To get rid of the square root. Very good. If we divide it by this amount, then we should multiply with the same amount to make it even, right? And to get rid of the square root of 3 in this term, we should multiply with 1 minus square root of 3 over 2. And the same story, we should multiply with this same thing. Okay? Simplify it. And in the end, it will be -1. So just double check it yourself. So observe in the second part B here, find the points where the cardioid here, the tangent is horizontal and vertical. Okay, very important that we should double check two things. If it is horizontal, we need to check dy over d theta is equal to 0, and dx over d theta should not be 0, right? Dy over d theta is given by this formula, okay? If this guy is equal to 0, the product of two things, what does it mean? It means cosine of theta should be 0, and or this guy is equal to 0, right? Very good. 1 plus 2 sine theta. If this is 0, then it means that sine of theta should be -1/2, right? Sine axis is here, and -1/2 is here. Then you will find two angles, right? The first one is this guy, which is -pi/6, but let us pick the angle is positive. If this is positive, then we just add 2 pi, right? At 2 pi, it gives us 11 pi/6. The similar story, this angle here is pi plus 1 pi/6, which is 7 pi/6. Okay? From cosine theta give us these two angles. From 1 plus 2 sine theta give us these two green angles. And okay, in general, dx over d theta, if it is 0, then we will find these three angles. Having these angles, we can find the points. Here, we must be careful when theta is 3 pi over 2, both dx over d theta and dy over d theta are 0. Because this is 0, we cannot compute, we should use L'Hopital rule to compute the limit here. Review the L'Hopital rule, the note is in Moodle's L'Hopital rule. And yeah, we prove it, therefore we find these. In the maps here, in the curves graph here, we see that these, the tangent line will be at this point. So 2 and pi over 2. This guy, this point, this point, this point, this point. The tangent line is horizontal at this point, right? Or vertical at this point, and yeah, at the pole here. Okay, let's double check it yourself, the remaining part. And I'll see you tomorrow.